Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Declarative Gradle, a developer-first approach to Gradle builds, are my two wonderful colleagues, Paul Merlin and Sterling Greene, two longtime senior engineers at Gradle. We also have Oleg Nanashev joining us and lurking on the side to answer comments. And if you've met Oleg before, you'll know that he's got the mastery of what we're looking to say here. If you've spent any time working with Gradle, then you probably know that there's a learning curve involved. And here at Gradle, we sometimes say, with great flexibility comes great power. Noting this feedback from our users, we introduced Declarative Gradle back in 2024. It's an experimental project, and it's now in its third early access preview version. The goal of it all is to provide an elegant and extensible declarative build language that enables developers to express any build in a clear and understandable way. And this is what Paul and Sterling are here to show us today. We're going to look at the benefits that a declarative paradigm for build definition brings to project workflows. So while we wait for folks to get settled with their coffee, tea, fizzy beverages, and so on, there's just a couple housekeeping items to go over. Today's session is being recorded and will be shared with you next week along with the slides. It will take about 45 minutes, plus we'll have time for Q&A afterwards for live attendees. We're also introducing some polls during the presentation, which you can access via your phone using a QR code or via browser. We'll take a small pause to collect the votes during those times. If you have any questions, please add them to the Zoom chat or send to me or Oleg privately, and we'll do our best to address them at the end of the session. Lastly, this webinar and all of our DPE events are made possible only by the support from our hundreds of happy customers, including Pinterest, who currently has over 40 software engineering positions open all over the world. If you're interested, search Pinterest Careers to learn more. All right, that's all from me. Let's hand it over to Paul and Sterling. Welcome, guys.
All right, thank you, Oliver. So I'd like to get going and we'll talk about what our agenda is for today. I'm going to kick things off, tell you what the agenda is, and then hand it over to Paul. We're covering challenges that we see in current builds, our vision for solving those challenges, some building blocks of what we've built so far, and then we'll have some live demos that Paul will show you. And at the very end, we'll talk about what's next, where we're going with all this, and how you can really help us out by providing some feedback. So with that, I'll turn it over to Paul to talk about some challenges and take it away.
Thank you, Sterling. Hello, everyone. So let's get started with the current challenges we identified with builds today. Like Oliver said, Gradle is flexible and extensible, but it comes with responsibility or drawbacks. We identified three main challenges. The first one is that build scripts are expressed in Gradle terms. I will get into more details about this later. That build scripts can become complex, and that the tooling around the builds, like IDEs, they can only help so much. So around all this, and to give some context, we know that Gradle is being used by a wide spectrum of roles, people wearing different hats. On one hand of the spectrum, the software developers, it's the majority in most of the teams. And the other hand, the build engineers that are more frequent in larger teams, of course. The software developers, they don't wake up in the morning to run builds. They are here to improve the software they are building, to ship features, fix bugs, etc. While the build engineers are here to create tools, maintain builds to make software developers productive. And in most teams in the world, it's often the same person wearing different hats depending on the context. So we wanted to ask you a first question. There is a QR code on this page, but yeah, Sterling just shared the link you can use directly in the webinar chat for our first question. So I'm gonna launch this question. Which role do you prefer? Software developer, build engineer, or both? Yeah, so in most teams, like I said, people have to wear the two hats. So the current results are not a surprise to me. Like it's both is largely winning. All right, looks like it's stabilizing. Yeah, but build engineer is last, right? So more software developer. All right, we have more than 50 votes. Let's continue. Thank you. So back to the challenges. The first one was that the Gradle build script are expressed in Gradle terms or the Gradle lingo. Like you need to know your Gradle lingo to evolve around build scripts. And it's not only about the terminology, but it's also that you have to deal with concepts that are far away from what you are currently building. Like, for example, if you're building a Java application, why do you care about tasks? What do you care about some names that are there that are not in your domain? And so it forces software developers to think about Gradle plugins, tasks, and other magic names. And that complexity you get over time in build scripts can get daunting, and it needs to be managed. Like, who hasn't seen a build script more than 500 lines long with a lot of complexity in there? And when you come back to it, it's hard to make sense of them. So another question for you: how often have you needed a flexible and extensible build system? I'm gonna start it. Sorry, first time playing with that type. So yeah, voting 1 means rarely, voting 5 is like always. So yeah, it tends to go to the always. Might be a bias in the audience towards being build engineers or alike. But yeah, sure. You need flexibility, you need extensibility. All right, we're reaching 60. Oh, so let's continue. So the next challenge is about the tooling. Like with such build scripts, with control flow, condition loops, functions, how can the tooling make sense of it? How can the tooling help you to manage, like automate change? It's very hard. And in that's the drawback of the flexibility of the build script being written in a programming language, like a command programming language, Groovy or Kotlin for Gradle. So another question again, how do you feel when you see a complex build? Mostly bad, but some people love it. Someone is genuinely happy, yeah, but the overall sentiment is pretty negative, right? And especially as a software developer, like as a build engineer, you can be like proud of the complexity, but as a software developer, it can make your task harder. Yes, Ole, 8% work in consulting, maybe. So with all these challenges in mind, we already have recommendations toward our users on how you can make your builds look declarative and deal with those challenges today. And those recommendations are like, the first one is pretty clear, like use convention plugins, but it's implied, right? But give them meaningful names so that software developers can understand what they are. So when you look at one build script, you look at the applied plugins and their names declare properly what the project is about. And the second one is to keep coding plugins. So that's like use convention plugin. And do that for two things, for sharing command build logic, but also for sharing command defaults. So command build logic will be, custom tasks, custom configuration logic, and custom defaults will be just values. Like for all my projects, they use Java 17, for example. And the corollary to these two is to keep all the build scripts simple and do not make use of the grid power you have in there. Like don't use too much code constructs like conditions and loops and etc. And that can give you something as simple as this. Like I have a plugin applied, it's a backend library, a few dependencies, maybe some more, but we were thinking this might not be enough. And so we came up last year with a vision and goals and principles to chase those goals. For the Gradle build tool, we have a vision statement that is put up on Gradle.org, and part of it is about this elegant and extensible declarative build language that allows software developers, to describe any kind of software in a clear and understandable way. And if we take a step back and look at Gradle today, yes, we know it's extensible and flexible. a lot. Declarative, it can be, but there are some holes. There are still some problems. Like, for example, the shared defaults. It's not declarative to put them away mixed into the logic for the build. And clear and understandable, I guess we could do better, because it's still very easy to mix up the scripts, and there is the terminology that's used. Like, software developers, they still have to learn about Gradle's kind of internals. So yeah, some good things, some bad things. And to move forward, we rooted our thinking into the need of our users, and we use that from like discussions, but also surveys and other tools. And Gradle needs to do two things, or you need to do two things when you use Gradle to put up a build. You need to come up with a software definition. That's what needs to be built. Like, I want a Java library for this platform and with these dependencies. And on the other side, you need the build logic. That's how the software is built. And this is about the tasks, providing capabilities to the build, integration with external tools, maybe orchestrating releases, etc. And so the first one, the software definition, should live in build files, and it's meant to be read and modified by software developers. And the second one lives in plugins, the convention plugins or external plugins, and is meant to be read and modified by build engineers, or the same person changing hat, but the two roles. And so with that in mind, our goal to make builds developer first are as follows: to clearly separate, like build a fence between the software definition and the build logic. And for that, we decided to use a declarative DSL, and we will go into more detail later. And to match the software definition to the software domain. So what does that mean? It's to make the software definition, so the thing that is meant to be read and written by software developer, match the software domain. So no more Gradle lingo, no more plugins, tasks, configurations, etc. And of course, we want excellent tooling for all that, so that IDEs and other tools like Open Rewrite, Renovate, Dependabot, and others can work with the software definition in a much easier way and a more intelligent way. And with that, I leave it to Sterling to talk about the building blocks.
All right. Thank you, Paul. So yeah, I'd like to talk about some of the building blocks to get to our goals. And first, I'd like to talk about some of the pieces that we already have. Don't mind going to the next slide, Paul. There you go. So we already have some pieces, like Paul touched on. We have convention plugins. We have Kotlin DSL to help with the experience. We have depending on the plugin of like Android or Kotlin or Java or whatever, we have also this idea of higher level models of what is the software that you're building. We have all these pieces, so we're putting them together. So ask a question here: how many convention plugins do you usually apply to a single project? And by convention plugins, we're talking about the thing that Paul was showing before, of like, this is what this project is. These are things that it needs to have to accomplish its goals.
So nobody voted 50 plus yet.
Should I just to be an outlier?
So let's try to get at least 50 votes. But there's a clear winner here. Yeah, we did put 50 plus just to see if anybody crazy was attending. All right. Tell me when you want to move on, Sterling.
I'll highlight one comment Jonathan just raised of I'm a hobbyist, so most of my projects aren't part of an organization. With convention plugins, you don't necessarily have to be thinking about plugins that published in multiple repos are using. It could also be like within one build, like you're going to have conventions. Okay, I think we can move on. So when we talk about convention plugins, one of the, I guess, problems with it is you have this mixed concerns. So here's like an example, like made up convention plugin that applies Java library to create some special things, a special task, configure some Java language levels, and add some dependencies, right? This does a splattering of things. We go to the next slide. If you're a software developer, you kind of only care about parts of these things, right? You care about saying, I'm a Java library because that's what I'm making. I want to use Java 17 and I have this dependency. Those are the three things that a software developer kind of cares about. But if you put on your build engineer hat, there's kind of like overlapping things, but also separate things. Like you're like, yeah, I care about this being a Java library, but I also need this special task because of something I need to do to make, to enforce some sort of standard or to catch some problem or to help out the software developers in some way that they may not, it's just they only care about the output. They don't necessarily care about how it's done. And so it leads us to this part where we have, go to the next slide for me, Paul, where we have a shared location, but separate concerns. And that kind of encourages a complexity where we put everything in one file or one place. And so that means that software developers need to wade through unfamiliar things that they want to make changes, or it means that the responsibility for software developer things now moves to the build engineers, where they need to maintain the software developer things so that they don't make a mess or something like that. That's sort of like this trade-off. And so we're really thinking about how can we split this? How can we handle this? And so if we go back to something that Paul mentioned, is that Gradle wants two things. It wants the what are we building, the software definition, and the how do we actually build it. So if we talk about how do we define the software definition, how do we define what needs to be built? And so we have this idea of in declarative that something we call a software type. It's a high level model. It's something that's like expressed in software developer terms. So a Java application or JVM application is a software type. A software developer knows I'm making a JVM application. They know what version of the JVM they want to run on most of the time. They know what dependencies they want to use. Those are things that they can sort of know. And then the software type kind of hides these low level details of like tasks and like how things get done. Those are kind of abstracted away from what the software developer sees. So if you look at what does this look like for software developers, in a project file, a software type is just this Java library block, right? There's no other blocks in the file. There's this is like 100% all software developers care about things that are in this block. So there's nothing interspersed like it was before. And as a build engineer, you might wonder like, what does this mean under the hood? Software types replace having to apply plugins at the project level. There's only a single software type for each project. You can kind of think of these as a project extension. That's sort of how they behave. Gradle's still using build logic and plugins under the covers to actually take the software type and turn it into what actually is going to be done, like what's the actual work. And it's been in all the EAPs, but our EAP 3 has prototype plugins that kind of demonstrate what this would look like. We have some sample plugins for JVM and KMP and Android to sort of demonstrate what this looks like in real life. Another thing that this sort of opens up is that with part of the reason that we use convention plugins and put kind of common shared things in convention plugins is that we want to share them. And software developers, it would be nice maybe for software developers to be able to share conventions without having to know how to make a plugin. And so this opens up this possibility for sharing just these reusable parts, just sharing just the software type defaults, is what we call them. We have APIs now, or we have ability now in a settings level file to say, here are the defaults for this software type. You can put in whatever you want. And then in the project, you can just use that software type in the actual build file, and you get those defaults being reused without having to go through any plugins or anything like that. So we have another question for you. I'll let you get that open, Paul.
Which DSL do you use today to define your builds? Kotlin, Groovy, or the declarative DCL? You can pick multiple if you do. Oh, we have some users of declarative, early adopters. Yeah. And so Kotlin is winning, but not by a huge margin.
Also, since you can select multiple, right? It could be that some people have just one, right?
Yep.
Yep.
All right.
So like the question revealed, right? We have this looking at how do we simplify the build scripts we have now that are Kotlin or Groovy that are full-blown programming languages. We have this new thing we're working on called the Declarative Configuration Language, DCL. It's text-based, human-readable, document-oriented. It's toolable. It's simple to parse. As an example of it, so then we have language highlights. The DCL is a strict, tiny subset of Kotlin, so we try to stick very closely to what the what Kotlin features, what Kotlin can do in terms of syntax. It's purely declarative with simple assignments and nested blocks. We forbid any type of code type constructs. That means like loops and imports and class literals and conditional statements and all of that. Like I said, we have a fast and resilient parser that we use for this that we can parse even when there are errors and kind of like make a best effort to make sense of what's in the file. Here's another example of like all the little things you can do. Like I said, we can have simple property assignments. We have lists and file references that we can append to a list or use what looks like like the layout API to get file paths to different things. And we also do some container stuff. I couldn't fit on the slide here, but you can also access containers. So when it comes to tooling, like IDEs, we can do some really interesting things, and we'll show those in a demo. We can request project definitions without fully configuring the build. So we can ask, what was configured in the build script without having to run full configuration. We can validate the project definition against the schema without having to like apply the plugins and extract the schema from it like we do today with Kotlin. And we can also do mutations programmatically on top of the build definition because you're operating on this simpler language. And so with that, I'm going to turn it back over to Paul, who's got some demos lined up to show you what you can do in EAP3. And go ahead, Paul.
Thank you. So we're going to take a look at what you can do today with Declarative Gradle. A small disclaimer before starting. Everything we're currently doing is constantly changing and breaking. So the sample projects, they do require Gradle milestones, not releases, unreleased features. The provided prototype plugins that have software types that Stanley mentioned are also changing all the time. And disclaimer, not ready for production use. And the IDE features we're going to demonstrate, they require Android Studio or IntelliJ nightlies. For Studio, the regular nightlies are fine. And currently for IntelliJ, you need to use a special build that was provided by JetBrains. So it's signed, but it does expire. And we renew that build regularly. All the links are available on the Declarative website. So let's look at some moving pixels. One thing we added in EAP3 is the ability to use Gradle init to bootstrap project with Declarative. So this is how you use it. All these instructions, everything you will see now is available on the declarative.gradle.org website. So this is based on a small change we did in building it, is that you can add pluggable generators there. So here it's a generator for the GVM ecosystem for Declarative. And when I run it, it tells me, do you want to generate your project? Say yes. And then I get the usual multi-project build with an application, and then 2 lists and utilities libraries. It's just a regular Gradle project, but the thing you can notice already, it's the script file name settings.gradle.dcl everywhere. All right, so let's open this with Android Studio. All right, this guy was located somewhere here. That's the one. And we find our DCL files there. So if we take a look at the application one, we find the Java application software type and the main class, the dependencies, nothing surprising, right? We are looking at a very simple project here. It's the output of Gradle init. In a subsequent demo, we will look at something a bit more interesting. But here we can already try out something. So we can see that the IDE provides completion. It's very fast. And the list is tiny because the only thing you get here is what's available in the schema of this software type. So it's very, that's the only thing I have here, the test Java version 17. And that's it. So it's very, very convenient and easy to work with. And the other ones, the list and utilities, they are simple Java libraries. And the settings file has some interesting parts. So it looks like a regular one, all this part. And we did not revisit too much the way things are modeled in settings yet. We have things in mind for that, but the thing that changes here is that we apply a plugin in settings, and that's the JVM ecosystem plugin. That's the one that provides the prototype plugins with the software types. And we need to apply it there because in the project file, we don't apply plugins. And so that it's available here in the settings already. And then we have this defaults block. That's how you share configuration in a software developer convey way. And we find our two software types, the Java library and Java application, that are configured with all the default value, default dependencies, default Java version, etc. So that's for the support you get in Android Studio. For the sake of it, we will open the same project in Visual Studio Code. So let me find it very quick. One, and you see fetching the declarative Gradle model. It's done. And then you get the same sort of help there. So the support in IntelliJ and Android Studio, we work on it together with the Studio team. And this support in VS Code is purely from us. We actually built a language server for DCL files. And here we show it integrated in VS Code, but it can work in any editor that supports an LSP. We tried in Vim and Helix, I think, and it was just working fine. So yeah, that's the same project, so I won't go over the thing. This one is more strict in this Visual Studio, but these are things that we will fix over time. So that's basically what you can do with ELP3. And so what we saw is that the ID support in Studio, IntelliJ, VS Code, code completion is fast and concise. And in VS Code, there are these, all the software types, they show these little bulbs. And these are actually semantic mutations that the language server provides to the IDE. And that allows to change the build script. So it looks like nothing, just like I'm doing something trivial here. But what's interesting is the way the mutations are formulated. We built an API that would allow like us, Gradle, or plugin authors, or ID vendors, or third parties, any third party, to provide libraries of mutations that work on the semantics of software type. And the mutations are, the code of the mutation is written against the types of the software type. And so you know what you're dealing with, and you don't have surprises. And what's interesting is that if I put some syntax error here, I still can set the Java version there and operate on the file, because like Sterling said earlier, the parser for DCL is very much resilient at the line. And so we can still work with broken files in the mutations. All right. So a little question after this. Which IDs do you use most of the time? And we have IntelliJ. We had to make choices, right? IntelliJ Studio, Visual Studio Code, Apache NetBeans, Eclipse, or others. And please feel free to share your Beloved ID in the chat. So interesting. We have more Visual Studio Code users than Android Studio in the crowd, and IntelliJ is a clear winner. And still users of Eclipse. So the language server we have for declarative, we did also make it work in Eclipse. It does work in Eclipse. No Apache NetBeans user. I'm sad. All right, thank you. So there are, of course, some limitations with that EAP3. The main one, it's like the elephant in the room, pun intended, that there's no composability or extensibility for software types. What does that mean? It means that you have an example of what it could look like if we had composability, extensibility. That here we have a Java library block on the bottom, and it has a nested block which says checkstyle. And checkstyle is another plugin. It's not the Java library plugin. It's the checkstyle plugin. And we still don't have that mechanism to allow plugins to extend and add extra functionality to an existing software type. So what does that mean as of today is that if you try declarative and you need to mix plugins, you have to write your own software type. Like you have to say, I will write a Java library with checkstyle, or my Java library, or whatever name, a meaningful one you use. You will have to give it a new name and give it a new type and do the wiring behind the scenes. And we will take a look at that. Other limitations are mostly missing support for some model types, like there is no file collection currently. And we use in our models, in our prototype plugins, we currently use a list property of regular file or a list property of directory for the same intent. In EAP3, there were no maps, but since then, we actually merged the support for maps on master. So maybe the next, it's on 9.0. It will be on Gradle 9.0. There are milestones already if you're brave. And no polymorphic domain object container. So we have support for monomorphic named domain object container, but we currently have no replacement for the polymorphic one. All right, so we looked at a simple example to see the basic IDE support and all that. Now we will look at a migration demonstration. So here we have the build of the Gradle client. The Gradle client is an application we developed to demonstrate how IDE could integrate with Gradle. So basically, it's there is a Gradle daemon, and here it's a Gradle client that can like query the daemon and interact with the daemon via the Gradle tooling API. But it's just a pretext here, and this build produces a desktop application, and it's a JVM desktop application built with Compose for desktop and Kotlin. And in there we have two libraries. The build action, it's a library built with Java. We have the mutation demo library. It's a Kotlin JVM library. And the Gradle client, which is a bit more complex. And this is the application that use Compose, Kotlin, and it uses Kotlin serialization, SQLDelite for a small embedded database, and Detect for static code analysis. And it has like a bunch of dependencies and configuration, like SQLite, Compose Desktop, and Detect. And so we ported that build from KTS to DCL. And so I have it open with DCL. And so if we compare, so that's the Java library for the build action in KTS and in DCL. And we see here, like we showed, it's clearer. It's only developer concerns. Another thing you can notice, we don't have version catalog support in DCL yet, but it will come. All right, and the Kotlin JVM library here. So there is one thing in common with these two, is that the Java library software type and the Kotlin JVM library software types are coming from you remember we saw in the previous example that we apply a settings plugin, the JVM ecosystem plugin. And we also have the KMP ecosystem plugin. It's the prototype plugins we talked about earlier. And these are provided by us, and they can be applied here directly because the build was simple enough for those projects. So we reused the existing prototype plugins for the migration. But for the Gradle client one, like the Kotlin JetBrains Compose for desktop with SQLite, etc., there was no out-of-the-box software type available. And because we don't have extensibility and composability, we had to come up with a custom one. And this one, we named it Desktop Compose App, right? And it has all the settings we need there, all the dependencies. We find SQLite there, but it's SQLite inside the Desktop Compose App. So there is always a single root block, which is the software type, and then nested blocks with the rest. And this custom software types comes from this plugin. And this plugin we call the custom ecosystem. It comes from an included build there. Just like you have build source or an included build for plugins. But there, our plugin, and it's itself also declarative because we have a plugin ecosystem experimental plugin for building plugins. That's a lot of plugins. And here we have the Java Gradle plugin with some way. And so this ecosystem plugin is just a settings plugin as usual, but it's statically annotated to say it registers software types with a list of types. And then what we see here is a plugin of project, because this will be applied to projects, right? That declares a software type. And to declare a software type, you need a name and a type. And that type looks very familiar. It looks very much like a project extension in the current world of Gradle plugins. But with these annotations, the names are to change. This is, again, early. But it's the basic idea. The interface here is basically the state of the configuration for this software type. So it's regular Gradle managed state, like properties, and then nested objects with more properties, containers. Nothing really surprising here. And then the plugin, when it's applied to a project, it gets the project definition, so the software type configuration state, and then apply to the regular Gradle model. Nothing changes here, right? There is some caveats about the life cycle, like you might need to use after evaluate a bit more than sane, but we are working on this too, so we see it goes. But that's basically how you do migration. So taking a step back, the main principle for the migration are reuse the prototype plugins when the modules are simple, because it's easy, and maybe start with them so you can get a feel of that. And write some software types when you cannot reuse these. If you can reuse our prototype plugins, it's very easy. If you can't, and if you are used to write Gradle plugins, it's not that hard. But if you are not used to write Gradle plugins, it's currently quite difficult. So to help with trying this out, we wrote a guide on how a migration process could be done, and a case study based on the project I just showed you, the Gradle client. And it goes in depth, like it goes over all the steps and all the challenges and all that. So if you're interested, please have a read. So after seeing that, another question for you, like how many software types do you think you'd have in your build? We move to it. how many software types do you think you'd have in your build? This question is kind of a corollary to a previous one, right? About the number of convention plugins you'd apply to your build, to your project. So yeah, for most folks, it's below 10, which is reassuring because in our mind, it was like that. Like you wouldn't get to like 40, 50 plus software types. And maybe 10, 50 was a too large range. But yeah, a clear winner on the 2 to 9. Cool. Thank you. And with that, I leave it to Sterling to talk about what's next.
All right. I'll try to be mindful of time here. So, our lawyers make us include a forward statements disclaimer. There you go. So, because like I said, EAP3 is out now. There's a blog post that goes along with it. It has some videos highlighting some of the same features that Paul just talked about. We're looking for feedback on this, and you should see all the new things that come in EAP3. If you go to the next slide. So I loop back around to like some of the challenges we talked about at the very beginning, about build scripts being expressed in Gradle terms. We see software types as a way that's simpler and more in the domain of the software developer. Talked about build scripts being complex over time. We say DCL files kind of contain that by preventing you having code and kind of multiple ways of doing things in them. And we talked about how tooling can only do so much before it kind of breaks down. And we showed that we have a lot of automated tooling built around declarative and the DCL and software type features. So we think we hit a lot of the challenges there. So we have a question. We'd like to know how many people who are here have actually already tried Declarative Gradle. A bigger group than I thought would be saying yes.
It's good. It means more people exposed.
All right, let's go back to the slides, just so we have more time for questions. So this is what we're asking for you. Is like you've shown some interest in what we're talking about. We'd love to hear some feedback. If you go to this link here, there's a form you can fill out to give us feedback. This is a chance to influence kind of like what we're working on and get early feedback on if we're going in the right direction. We're especially interested in software developers who maybe don't know Gradle very well. Like if you're not one of those people, that's fine. But if you know someone who is, you can like show them like, oh, is this better? Is this good or whatever? Feel free to submit on their behalf. We don't mind. If you don't want to do the Google form, there's also Slack and GitHub link from the same place where you can provide feedback that way as well. That takes us to our roadmap. Right now we're kind of distracted on getting the next major release for Gradle out. So Gradle 9 is underway right now. Once that's done, we'll start back up on what EAP4 will be. We have some ideas in our roadmap about composability and extensibility being a part of that. More DCL features, and this is something coming in the autumn Q3 of this year. You might also be asking, when is this going to be incubating? Everything we've showed you so far is like less than incubating, experimental, changing all the time, breaking. A lot of that depends on the feedback we get from EAP3 and EAP4. Also, we have work to do to make built-in plugins compatible, and any type of stable GA type of thing would come after that. But the plans right now are to try to make incubating happen this year. The last thing I'd like to highlight is this is a team effort. You heard only from us, but we have weekly meetings with people at Google on the Android Studio team and JetBrains talking about this. And there's a blog post by the Kotlin Foundation relatively recently where we talk about making a better developer experience is like an effort that we're all trying to work on, and we see this fitting into that. All right. So thank you for listening to us ramble for almost an hour. And if you want to find us on socials, I don't have anything other than GitHub, so you can find me there. And then you want to go to the last slide? Yes. I'm surprised that was not taken. So yeah, this is the last slide. And we'll take questions. There's a QR code here. I don't know if Oliver, you have anything more specific you want to spiel here, but there's a QR code here.
I've got a spiel for you.
All right, I'll shut up then. I'll let you do it.
So I imagine that most of the people joining us today are using Gradle professionally. And if you're using it in a team, we want to invite you to a guided trial of Develocity, which is our toolchain observability and build acceleration platform. The way a guided trial works is over a few weeks, you'll work with our expert engineers hand in hand. We'll securely set up Develocity in your own environment, take a look at your build, and start to be able to decide whether we can add features like build and test acceleration, predictive test selection, flaky test detection, failure analytics, and a bunch of other things. And at the end, you'll be able to show your management team a proven ROI using your own project. So check that out at gradle.com/trial, and you can tell them Oliver sent you. All right, we've got some questions coming in. Now, guys, it's up to you. What's your preference here? Would you like to go through the chat yourselves? I can read them out to you. There's also some longer one. There's a very long question that's a little bit impossible to read in the Q&A tab. So what's the preference here? How about I read it out to you? All right.
Yeah, you read it out to me. You tell us, you help us find it.
Good. Question number 1. Does the migration guide talk about how one would try out the principles of DCL in a production project that can't use the EAP? In other words, how would I get our build ready to adopt DCL once we can?
I can take that one. So it was a question from Jamie. Thank you, Jamie. So basically, the main thing you could do upfront is to refactor your build so that you architecture your own plugins as software types. Like you keep using Groovy or Kotlin as you do today, but you have one conventional plugin per software type. And if you structure your build that way, you will be very close to the structure you need for DCL to moving to software types. But yeah, of course, like the migration guide doesn't reply exactly to that question, but it gives a lot of hints. For example, you need to move to software types first because you can actually use software types from Kotlin or Groovy scripts. So there is a path for the migration there. Like you move to software types and then you can use software types in your project script, but still have some clunky code in your scripts because you need it while you're migrating. And once your Groovy or Kotlin file is like pure software type, then you can switch to DCL and then lock in the declarativeness. Yeah, I hope it answers your question, Jamie.
Great. Thanks a lot, Paul. Next question. Can you mix and match for migrating a project for build scripts and declarative, or does one need to be doing it all in one go?
You can have a mixture of Kotlin, Groovy, DCL, whatever. It's like it's one per project, but within the build, you could have a mixture of script types.
All right. Thank you, Sterling. Here's a question. For those of us still using Groovy who are considering switching to Kotlin, would you recommend we wait, skip colon, it's Kotlin, colon, and go straight to DCL?
I'll take this one. So like Sterling said earlier, the DCL language is a strict, tiny subset of Kotlin, meaning that when you do your migration to software types, still using KTS, once your KTS is pure software type, you just rename it and the syntax will be the exact same for DCL. If you're coming from Groovy, you can do that, but with a lot of discipline, like always using parentheses, always using double quotes, and there might be some differences that will get in the way. But both strategies will be valid. I guess it depends on the amount of build script you have compared to the complexity of your software types, where the most of the work of the migration will be.
I would also slightly the same. I agree with what Paul said, but also there is a motivation to migrate from Groovy to Kotlin, or there should be a motivation like in itself to migrate from Groovy to Kotlin because of IDE support or whatever. And so like I wouldn't hold off going, oh, I'm going to wait for DCL because it's going to be even better. Like if it's painful now, going to Kotlin, if then Kotlin solves that for you, like go ahead and do it. Like it's the problems. I don't want to say problems, but the downsides to Kotlin sort of show up when you have like really big projects, because like script compilation becomes a problem. But if you get a lot of other benefits in terms of IDE support and everything else with moving from Groovy to Kotlin already.
And it's a good segue to another question in the chat that says, from Leonid, I work with a large Gradle project, like 500 plus sub-project, and I want the fastest possible local builds IDE syncs. Will DCL be faster than Kotlin? So DCL today is roughly as fast as Groovy, so faster than Kotlin. And we did not try to optimize yet. And we know there are ways we will make that faster. So we expect DCL to be faster than Groovy is currently, so faster than Kotlin.
Great. Thanks for that, guys. There's a question out there about what's the future of the Groovy and Kotlin DSLs? Do we have any specific plans in mind yet, or continued support, etc.?
So the status quo today is continued support, because so declarative first. Declarative is an experiment still, and not incubating yet. But Groovy and Kotlin, so DCL pose no challenges on supporting the other DSLs yet. And Groovy and Kotlin is the favorite DSL, right? But we continue to support Groovy for now. We don't have a clear plan about that yet. We know, but maintaining both DSLs, like Groovy and Kotlin, makes it harder on us because it's more to maintain. Not only the code for running all that, but the documentation. And it's also kind of a burden for plugin developers, because they also have to make sure their plugin works on both DSLs and document both. So we know that the community at large is wondering about this, but we don't have a clear plan yet around this question.
Right. Well, folks, that's all the time we have for today. Thank you to Paul and Sterling and Oleg for joining us. We hope you enjoyed what we had to show you today. If you have any questions, you can contact us via the emails that you may have received, and that's the best way to get a hold of anybody. So thank you all for joining us, and have a wonderful day.
Thank you.